So we're going to move on and look at special relations. Now the key thing here is a function is a relation, but it's a special one. So let's start with a definition of a relation. A relation is any connection between set 1 and set 2. Now the key thing about a relation is there's not a rule about them. You could have one x with two different y's at the same time. And I always like to use the comic strip Archie, or Riverdale if you've watched the show, in that everybody seems to be dating everybody. So you can have one person in a relationship with two or even more people. Now on the opposite side, a function, I always think of it as a wedding function. It's special. There's 1-to-1. So there's no cheating allowed. There's one relationship, one connection between the x coordinate and the set 2 coordinate, the range. So the key thing here is, let's take this as an example. We've got Marvel, Black Panther, Marvel and Thor, DC Superman, DC Wonder Woman. So the key thing here is, with this, we always want to look at the x coordinate, and it kind of doesn't work with the y's. The y's are allowed to cheat, but if it's a relation, the x can cheat. If it's a function, the x cannot cheat. So if we look at this, the first thing to do is cover up the y coordinates, the set 2. And we see that we've got Marvel twice. And if we uncover it, we see that Marvel is connected to two different superheroes. Therefore, it is a relation. And it's a relation because Marvel is connected to two different things at the same time, which is not allowed in a function. So it's a relation, but not a function. And in this particular case, DC also has two different connections. Now, if you go to the second one, pause the video, ask yourself, is it a function or is it just a relation? So if I cover up the second unit, I've got 4 different superheroes. They're all different. Therefore, there cannot be any cheating, at least on this side, because there's 4 different things. And again, it doesn't matter that there's multiples over here. What matters is the set 1, the x coordinate. Next one, I'm going to cover up the y coordinate, 7, 8, 9, 3 different options, cannot be any cheaters. So this is also a function. Doesn't matter that the y is repeated. What matters is there's no repeats on the x coordinate. And finally, this one, I'm going to look at it. I've got 13, 17, 12, and 13. Right away, I see there's 2 13s. I need to check if it's cheating. And I've got 13 and 5. Oh, wait a second. 13 and 5. It's the same point. So I don't even need this because it's a repeat. And once I get rid of it, there's no cheating. 13 is only with 5. This is a function. So just to review, a relation can have more than one different outcome for each x value. A function, every x value must only have one option. It can't cheat with multiple different y options. So now we're going to look at graphs, and we need to be able to look at a graph and see if an x value is cheating. So again, an x value cannot have more than one y value. So the first one, and we call this a vertical line test because we take a ruler, we take a pen, and we just slide it vertically. Careful not to do it horizontally. So always vertically. And you'll notice at the beginning, I don't even touch any x coordinates on the line. Once I get to here, I'm touching one single point. This value is not cheating. But as I move along, there's 2 different points that I'm touching. The ruler's touching 2 points, so it means the x is cheating. So it doesn't matter, as long as it happens once. If there's any cheating, this is a relation. Now I'll go to the next one. I take my ruler, use a pencil if you don't have a ruler, and slide it across. At no point do I touch 2 points on this curve. So this is a relation, or a function. Nobody's cheating. It is a function. And this final one, I'm going to do the same thing. And most of the points, I'm only touching 1. But when I get to this point, at 1, x equals 1 is cheating with 2 different y values. It's got 2 different. So in this case, it's a relation. So if you have 2 or more points, it's a relation. And it doesn't matter where it falls. If it happens once, it's a relation. So some key words. Domain. Domain is always the x values, the set 1 values. It's also called the independent variable when we graph it. Range is always set 2. It's the y coordinate, and it's the independent variable. So different names. Typically, math class we use domain and range. If you go into science, you'll see independent and dependent variables. And finally, I've got an example here. State the domain and range for. So we'll start with domain. Domain is set 1. So the first item in every ordered pair. Now the range is set 2. So I'm going to put an arrow towards, and you'll notice we have 2, 2, and 3. And I don't want you to repeat the 2. You only need to put it once. The range has 2 and 3 in it. Put it in numerical order. That's it. So to review everything, function and relation, we have to check for cheaters. So a relation is where we have one x coordinate or set 1 element that is cheating with more than one person at the same time. The function is special. Nobody in set 1 is cheating. So we're looking for cheaters, and that determines if it's a relation or a function. Number 1, arrow diagrams. We're looking for 2 arrows coming from one set element. We can see here in the first set, 2 has an arrow going to 2 different numbers in set 2. 2 is cheating. It's a relation. If we go to the next one, we can see 3 different elements in set 1, 3 different arrows. Each one only has 1. Nobody is cheating. It is a function. And the third one, we can see that there's 2 arrows going into the same number, but it doesn't matter about set 2. What we see is that set 1, there's 5 different elements. Each one has a single arrow coming out of it. Therefore, it's a function. It only matters if set 1 is cheating. The next thing we can look at is ordered pairs. We always have to look at the x coordinates for each ordered pair, see if there's any duplicates. So the first one here, we have 3, 4, 5, 8, 3, 9. Automatically, we see there's 3 in the first and the third one. 3 is cheating. 3 is with 4 and 9 at the same time. Therefore, it's a relation. If we go to the second set group, we've got 3, 8, 4, 8, and 5, 9. Right away, we look at the x coordinates. We've got 3, 4, and 5. Each one's different. We can't have any cheaters. It is a function. No cheating in this one. Doesn't matter that 8 shows up twice in set 2. It matters if set 1 is cheating. And the third one is graphs. The graphs is a nice and easy one. We just take a vertical line and we slide it across the graph. If you notice at any point that it hits more than once on the curve or the line, it's cheating. That particular x coordinate is cheating. In this case, we've got 4 different times it crosses the curve. It is a relation. If we continue on with the other ones, this one, we can't find any situation where it's cheating. So it's a function. This one, same thing. There's never any duplicates. There's never any cheaters. And the final one, we see right away, it hits twice. It is a cheater. So for this particular one, we've got a relation, function, function, and relation. Now the last thing for functions is something called functional notation. It's basically rewriting an equation in a different form. So the whole point of a function is we take something, we put it into some kind of formula, we treat it, and we get a number or a value that comes out. So what we're going to do here is, instead of writing it as y equals x plus 3, functional notation just says f of x equals x plus 3. It's saying what is the value of the function at point x when the equation is x plus 3. So it's pretty easy to change. If I've got this as my equation, I'm going to rewrite it with an f bracket x bracket. That's all I have to do. It's the same thing. You can go back if you prefer this. You can use it. But this is just another way to look at an equation. Now, how do we use it? Take this one, for example, f of 3. It means that we're going to take all the x's and replace them with 3's. So here I've got f of x. It becomes f of 3. The x becomes a 3, and then I do the math. And so if I put 3 into the equation, I get an answer of 6. The output is 6. This one's a little different. F of x equals 7. We know the answer. We don't know what we started with. So what we're going to do is we're going to put the 7 here. That's our answer, x plus 3. We don't know what we started with. We're going to use algebra. And we get our answer. So we know that if f of x is 7, we started with a 4. X equals 4. So when we're given the answer, we have to use algebra to work backward. When we're given the number in the brackets, we just plug it in and calculate. So try these on your own. Pause the video. Once you've gone through them, even if you get stuck, then play the video and see the answer. So here's my equation, f of 3. And so I get 3 and 16. And it's common to put it in an ordered pair. I started with a 3, I finished with a 16. Back here, 3, 6. And this one, 4, 7. This one's a little harder. We've got a squared in the equation. Remember BEDMAS, we're going to square, get the exponent, then multiply. There we go. Again, we put in set 1, set 2. This one's different. 37 is the answer. So I'm going to replace f of x by the 37. And you can see f of x equals 37. And I'm going to divide by 7. And I get 6. The key thing here, 6 is the set 1. 37 is the set 2.